Hey everybody. Today we're going to start talking about some naming compounds. We're going to start with the ionics. You guys should be able now to decide if a compound is ionic or molecular, right? If it's a metal and a non-metal, we know that that's going to be ionic. If it comes from either side of this staircase, we're talking about ionic compounds, right? One of the metals over here, right? We're just talking about the first 20. Sure, we could talk about all these. We'll just stick with these for now. And a non-metal. Most of the ones in the blue are non-metal. Just be aware of aluminum. Good thing aluminum is an obvious one. That's right, like this aluminum foil or something like that. We know that is a metal. It's shiny, it's lustrous, conducts metal, or sorry, conducts electricity. All the stuff that metal does. So if you don't have your periodic table out, can't do chemistry without a periodic table. So just pause the video, open P table if you don't have a printed copy. Just get a periodic table available to yourself. Okay, hit pause, go get one of those. So for naming ionic compounds, we're going to start with ionics. I think that they're a little bit easier. Not that the moleculars are very difficult. They're just maybe one more step. So I'm going to give you a few examples, and then we're going to try to build a pattern to see how we can name all of them. Okay, so let's start with something like LiCl. Okay, so we'll go back to our periodic table and figure out what these are. Li is a metal. Okay, number 3, lithium. Cl, we should be familiar with, is chlorine, number 17. Okay, we've talked about how lithium has one valence electron to give up, right? It's in group 1. It has one valence electron looking to give it up. And we've talked about how chlorine is so close to 18 there, also looking to gain one. So this is a nice pair where lithium's trying to give one up, chlorine's trying to get one. So you'll see that I wrote this as 1-to-1, and we'll get more into the building in a bit. But so we have lithium and chlorine. And how I'm going to write this is going to be lithium chloride. Okay, so let's try another one, see if we can start to catch a pattern. Na2S. So Na, something we should be familiar with. S is sulfur, so Na, sodium. Sulfur is S. Okay, so we have sodium and sulfur. Let's see how those go together to make a compound. We have sodium sulfide. Okay, you'll see some places spell sulfur or sulfide with a pH. Both are accepted. So if you see the pH, it's not something different. I know there's a lot of, again, this chemistry grammar that floats around, but this one, sometimes you see that pH, and that's okay. Let's try one more. MgF2. Okay, so go to the periodic table, figure out what elements we're talking about. Mg here, number 12 is magnesium, and number 9, fluorine. Okay, so magnesium and fluorine come together to create magnesium fluoride. Okay, so here's a few examples. Let's try to build a little bit of a pattern. So there's a few things that are happening that we should talk about. First of all, let's just talk about the compounds themselves. Okay, so first, on the compound side, right, we always have the metal first, followed by the non-metal. Okay, so we can kind of draw this line right down the middle. It's always right. I didn't show it very well. Metal's on one side, nonmetals on the other. Okay, so this is ionic compounds, metal, non-metal, right, on both sides of the staircase. That's how we know. And so we know the metals come first, and then followed by the non-metal, which is nice because on our periodic table, that's left to right as well, usually the way we read. Now let's talk about the name. So what we'll notice is that the metal, let's start with lithium, right? Lithium, this is just the full name of lithium. So it's just right off the periodic table, it's just lithium. Okay, then chlorine, right, Cl, has been changed a little bit. So it has the root of the word, but it's not chlorine, it's chloride. Okay, so there's a little bit of a change there from lithium chlorine to lithium chloride, right? Lithium and chlorine come together to create lithium chloride. And all this means, this "ide," and we can kind of think of this as this is an electron has moved. Okay, so we'll see this with the sharing in the molecular compounds. We'll see it here as well. So the metal stays the same, and the non-metal has the root of the word, but it's always an "ide" ending. So you could probably take a guess at what the next one would be, right? Is sodium is the metal. We take the full name. Sulf, right? The root of the word of sulfur, and we just need the "ide" ending. Okay, so let's try a new one and see if you guys can get it. Okay, so let's try CaO. Okay, and a small point, this is going to be a solid, and we'll talk about why later. So pause the video, take a shot at it, and then we'll catch up and see if you guys were able to do it. Okay. So Ca and O. Okay, we'll go back to our periodic table, make sure we got the right elements that we're talking about. Calcium, Ca, number 20. Oxygen, we know that one, number 8. Okay, so they come together 1 to 1. Calcium's looking to give up 2 electrons. Oxygen's looking to gain 2 electrons. It's a nice match. So to name these, I'm again going to name the metal first, calcium, and then we can look at the oxygen. And now we just need the root of the word, and this one's a little bit different than the other two. It gets cut off quite a bit. It ends up being calcium oxide. Okay. Another thing you'll notice is I've made a couple of mistakes. I'm trying not to use any capitals. Again, one of these chemistry grammar things. When we write out the names, we try not to use capitals. If you guys are using capitals, am I going to take marks away? No. But again, just best practice kind of stuff. So if you're able to do that, pat on the back. Let's try another one. Okay, or high five. Okay, let's put BE. We got to find that one, and okay, fancy one, right? We got 3 BEs, 2 N's. Let's go to our periodic table and figure out what we're talking about. So Be, beryllium, and N we know is nitrogen, so we can see those two coming together. Nitrogen's looking to gain 1, 2, 3. Beryllium's looking to get rid of 2. So that's why we have these large numbers. It's kind of a weird mix match here. So again, pause the video. We have beryllium, we have nitrogen. How are we going to name this? Pause the video and we'll see if we get it right. Okay, so beryllium, see right there, I made a capital, so I'll scratch that out. Beryllium is our metal, so it gets its full name. And then we have nitrogen, so it's going to be nitride. Okay, with that IDE ending. Okay, so these are our ionic compounds, and there are some other ionic compounds that we will talk about, but these are the standard ones, right? These are the ones that are from 1 to 18 on our periodic table. Those are the simplest ones. We need to know these ones before we can kind of move on and talk about the ones in the middle, right? There are transition metals. Those ones get a little bit trickier. And then for the reason being that they don't always have a standard set of, sometimes copper wants to gain 1, sometimes copper wants to give up 1, and sometimes copper wants to give up 2. So, and the same thing with nickel and a few other ones, and sometimes it's 2 and 3, sometimes it's 3 and 4. So we have to learn about those still. And then there'll be something called polyatomics, which poly meaning many, atomic meaning atom. So these polyatomic, basically little compounds that make ions. So we'll talk about those as well. But for now, I'll send you guys out a worksheet just for focusing on these. Can you knock these off following this pattern, right? It's when we're making the compound, metal, non-metal, and the same thing with the name metal, non-metal. We just need to make sure that we have the "ide" ending on our non-metal at the end there. So again, feel free to message me if you have any questions. The worksheet will be coming out shortly. It'll probably be attached actually, and we'll move on to the moleculars next. This is also in your textbook, so if you guys need a couple more examples, or there might be, I think there's some good diagrams about the naming as well. So in your textbook, I'll try to attach the actual page numbers to the assignment as well. Other than that, enjoy. Again, hopefully this worksheet takes you about half an hour. Again, that's your day. Have a good weekend, and I'll see you guys next week.